Hi guys. Hope you guys are doing okay. Just wanted to make a little quick video. I know there have been a couple of questions regarding some of the lab regarding Web 4 and how that lab kind of works, and especially with the lab quiz. So what I wanted to do is I took some of the problems that we can get from the lab quiz, and I wanted to show you how I kind of work my way through this, showing you my thought process and how I would answer this. So we'll start off with the first question and then we'll kind of like go from there. So for this first question, it says the following. So suppose that we have a rectangular carton that can fit exactly 27 eggs, and we have F friends. We want to assign each friend an equal amount of rows or an equal number of columns. What is the largest group of friends for which we can guarantee what we call row or column assignment? So first things first, the word "and" is a typo. So we what we're really saying is that we want to assign every friend an equal amount of rows or an equal number of columns. And we have to figure out how many friends this allows. So, and the question is, so the question becomes simply, what, how big is our friend group so that we can guarantee that every friend has either an equal number of columns to themselves or an equal number of rows to themselves. So this is a little bit wordy. So kind of what I would do to help make more sense of this is kind of take each of these word or each of these sentences and translate them into kind of a symbol, some sort of symbols, maybe with divides, maybe with equations and stuff like that. So let's call this my solution. So let's start off with the following. We know that there is a rectangle, so we know that there is a rectangular carton, and this carton can fit exactly 27 eggs. So let's just take that and see what we can write with that. So we know that this, geometrically speaking, this egg carton that we have been handed is in the shape of a rectangle, and this carton holds exactly 27 eggs. That essentially means that the entire space of the carton is completely filled up by these 27 eggs. So that means that there are no empty spots and all 27 positions are filled. Well, when we talk about no empty spots, we're saying that the space is occupied by an item. And when we're talking about geometry, space refers to what we call area. So what we're really saying is that the area of a rectangle is being occupied by 27x. So really, what we are saying is that the area of this rectangle is equal to 27x, because the entire space within this rectangle is filled up by 27x. Therefore, we can write the following. We know, and what we can say is this: we know the area of a rectangle is given by simply length times width, or in our case, to make it make sense and to make it make a little bit more sense in the context of this question, what we're going to say is that area of a rectangle is equal to rows times columns. So therefore, thus, what we can say is that since the area of this rectangle is equal to 27 eggs, what we really can say is that 27 is equal to R times C. And we're going to put a little bit of a criteria on what R and C is, where R is going to represent the rows and C is the columns. So that's how I would express that first sentence just purely in mathematical terms. What we're also going to do is we're going to create a little bit of a constraint on R and C. In the context of this question, it doesn't make sense to have 0 rows or 0 columns, nor does it make sense to have a negative row or negative column. If we have 0 rows or 0 columns, then we don't have a current to begin with, and if it doesn't really make sense in the real world to have a negative row or negative column. So really, the measurement of a row and the measurement of a column is given by positive integers. We call those positive integers natural numbers. So what we're going to say is that furthermore, we can safely assume that R and C must be natural numbers. Because the idea is that there's no negative rows, there's no negative columns, there's no 0 row, there's no 0 column. So it's got to be some sort of positive integer. Positive integers is what we call, at least in this class, natural numbers. Hopefully that makes sense for my explanation on how I generated this formula. So that takes care of that. Now we have F friends. So supposedly we have F friends. We don't know how big F is. That's going to be actually our goal. We can make an assumption on this though. We're going to make an assumption on F though. And that assumption is that F has to be a natural number. Again, it doesn't make sense to have a 0 friend. It's a little bit weird. And doesn't make sense to have a negative friend, at least from the mathematical perspective. Maybe from personality perspective, it might make sense to have a negative friend, but at least from a mathematical perspective, it doesn't make sense to have a negative friend. So since we can't have negative or 0 friends, we have to have a natural number of friends. So we can make that assumption. And our goal is find F so that every friend is guaranteed either an equal number of columns or an equal number of rows. And so this is a little bit, and so this goal we should try to translate into symbols, just like we did with our previous ones. But it's a little bit more tricky to translate this one. So let's kind of break this down. So get each friend is guaranteed an equal number of columns. So this one's a little bit tricky because we're saying that everyone gets the same amount of columns. Well, if we know that C is representing the columns, we can say that's what we really can say is that C divided by F has to equal some natural number X, where X is a natural number. Same thing can be argued for rows. That is, R over F is equal to, let's say Y, where Y is a natural number. Well, if we solve these equations, solving each of these equations, what we have is the following. So if we solve each of them, let's suppose we solve them for the columns and the rows respectively. So let's say solving each of these equations, what we have is the following. So we can say that C is equal to Fx. And what we can say is that R is equal to Fy. Because we're just really multiplying both sides of the equation by F respectively. So now we have these equations. But notice something important. All numbers are defined to be natural And really, natural numbers are just positive integers. What we're really arguing here, what this turns into is, since we know that f is non-zero, because has to be natural, and natural numbers can't include zero, at least in our class. And we know that x is a natural number, which is a subset of integers. We can argue that by the definition of what we call divides, we can say that f has to divide c. And in a similar way, we can argue that f divides r. So really, what we're just saying is that can f divide c or f divide r? And if we put all the information together, since we are trying to guarantee one of these two, at least one of these behaviors. We get the following proposition. So what we'll get is the following proposition. Because we're trying to guarantee no matter what c and r is, what we're going to really say is that for all c and r in the set of natural numbers, what we really have is that f has to divide c or f has to divide r. One of those two guys have to appear out of one of these two guys, or one of these two behaviors have to appear in order for this statement, or in order for this question to be satisfied. So given that 27 is equal to RC, we need to find f so that one of the behaviors above is satisfied. And so the question is, well, how do we get going from this? This is all nice and well, but like, how do we get about this? So what we're going to do is notice that 27 is equal to RC. So notice that 27 is equal really to the product of two natural numbers. What we really can do here, is simply come up with all possible combinations to get 27. That is, what are the possible combinations of two natural numbers that when multiplied gets 27 as a result. So simply put, what are the factor pairs of 27? And if we try to factor out 27, then what we get are the following factors. So the factors are 1, 3, 9, and 27. So if we just factor, we're just coming up with all possible factors that 27 is divisible by, and we get 1, 3, 9, and 27. Now, each of these factors are grouped in two, because by themselves, factors don't just result in multiplying a factor by itself doesn't result in 27. You got to take any two of these factors and multiply them together to get 27. So for example, 3 and 9 are grouped together because their product is 27. And in a similar argument, so too is 1 and 27. So our factor pairs we only really have two factor pairs for this guy. 1 times 27, and we have 3 times 9. And so now we have these guys. So the question becomes, well, what do we do with this information? Well, notice that really these factor pairs all equal 27. So in other words, R and C are coming from the factor pairs, from the factors themselves. What we're really saying is that create the factor pairs of the number of eggs and take any one of them, really. So for example, a possible combination of possible values for R and C are 3 and 9, respectively. Because 3 times 9, that's equal to 27, or R could be 9, and C could be 3. And so on and so forth. And so now the idea is that we need to find F. Remember, F needs to divide either the row, the number of rows, or the number of columns. And if you notice, we could have 1 times 27 or 3 times 9, one of those two, right? So in other words, whatever F is, it has to divide at least one number in each factor pair. The idea is that because we don't know what R and C is, the idea is that F should take essentially every possibility into consideration. So no matter what F is, it has to be the case that it needs to divide one of these two numbers here, and it needs to divide at least one of these numbers here. And so the question is, what is the highest number I can push F to get that behavior? And if we notice, note that at 27 and 9, the highest numbers in the pairs are all divisible by 9. So what we could do is set F to be 9. That guarantees that at least one value, either the row or the column value, will be divisible by the number of friends. And that's what we want. We want at least one of the values. We don't need both of them. We just need one of them, either the row or the column value, to be divisible by the number of the friends that we have. And so therefore, since 9 is really the highest we can go, because past 9, for example, if we say 27 doesn't divide any one of these numbers, so we can't pick 27 for that. So since 9 is the highest we can go, since 9 is the highest value we can find, it is the value we are looking for, which is what we need. Again, this is a bit more tricky than normal, but the idea was that what I do is I take my English sentences, translate them into symbols, and then kind of work from there. Hopefully that does make a little bit more sense in terms of how I did this question. Okie dokie. So now let's try the same thing. So let's try the similar thing just for 36x. So this is a similar argument for the problem above. So for this one, what we have is that 36 has to equal RC. Assume the variables carry over from the previous problem. So assume that 36 is, so what we have is that 36 is equal to RC, because this rectangular card now holds 36 eggs. our goal is still the same as the previous problem, which is trying to show which is find f such that the following is true. So our goal is to find f such that the following is true, that no matter what r and c is, as long as they're natural numbers, what we can say, we can need to say that f divides r or f divides c. And again, just like last time, we should look at all possible factor pairs. Should look at all possible factor pairs of 36. And so the factor pairs that we have for this is 1 times 36. We also have 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And so again, now we need to find f so that f can divide at least one of the two numbers in every factor pair. And if you notice the highest numbers in each factor pair. So when we look at them, the highest numbers in each factor pair, that's going to be 36, it's going to be 18, it's going to be 12, that's going to be 9, and going to be 6. They all share a common factor of 3. So since they all share a common factor of 3, that's the highest we can go without causing any problems. If we go any higher than 3, we're not going to be guaranteed that all factor pairs are going to be divisible by the number of friends, or at least one of the factor numbers are going to be divisible by the number of friends. So since 3 is the common factors between all of the highest numbers, just in each factor pair, we should set f to be 3. And so thus 3 friends is the highest number we can get. And so that's kind of how I would, if I'm speeding it up a little bit, because it's still the same question, just a little bit higher numbers and a little bit more math, that's how I would explain at least those 2 questions. And I'll create another video that explains the other 2 questions, those being the packages. But for now, I thought that this would be a little bit more digestible, and I hope this explanation helped you guys with at least those 2 lab questions. I'll send out the explanation for the bagels one soon. And until then, thank you guys for watching, and take care, guys. I'll see you in the next one.